Okay, hi guys, welcome back and let's solve the problem 947. Most stones removed with small same rows and column. Okay, so this is an interesting question. Maybe you will say it's a matrix question or you will say a graph question, but let's see. Okay, let's see. Suppose what this question is saying is, let me just give you the brief introduction by the matrix. Okay, so next to it there are two columns and two rows. So let's create. Okay, so yeah, perfect matrix. Now let's mark few ice like this, 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 and 1, 2, 2, 1, and 2, 2. Okay, so these are some stones lying on a matrix. Okay, and what you have to do is you have to remove the stones which have the same row or just listen to carefully or the column. Okay, so let me just show you. What if I say uh, take this? I can remove this stone because in this row there is another stone present. Or if I take this, I can say in this column there is another stone present. So I can remove this. Now I move to this. Now is a stone present in the row? No. Is stone present in the column? Yes. So remove this. Now same. If it is in this, it is present, so we can remove this. We can remove this. Now, in this portion, I can remove any of it. So how many stone did I remove? 1, 2, 3, 4, 5. So answer is 5. Okay. Now you will say, yeah, I got the question, but how should we solve this? Okay. Now there are two options. Okay. Now let's solve understand it deep. Now, if I say if I'm standing here, then I can remove this. If I'm standing here, I can remove this. So basically, if I traverse in 4 directions and if another stone present in any of them, I can remove all of them. Okay, so if I start from this portion, I can remove this. Okay, now the starting portion, I can remove this. How many? So I can make a Iceland for. So means if I make a Iceland from the stone, then I can remove all the stones. So if I'm standing here, so let's make an Iceland. All the stones that are connected like this. And in this, all the stones that are connected. Now, in every Iceland, I can remove all except one stone. Means I can remove a whole Iceland except I have to leave one. Okay, like this. And why I'm saying this? Suppose, like, let me explain you why I'm saying like I can remove all the stones except any of one. Suppose this is connected. If I'm standing here, this is connected, this is connected, this is connected. These two are connected, three connected, and this connected. So I can say this is an Iceland. And I can remove any, I can leave any stone and I can remove all of them. Okay, let's think why I'm saying this. Take the pen and why I'm saying that key. I can save any one stone and remove all. Okay, this is first condition. Because if I want to save this, then I can start from this stone and I can traverse all and remove all. Okay, this is the question. Now, I understand that if I make an Iceland, I can remove. Now, first, if I made an Iceland, stupid. Ah, yeah. If I made an Iceland, then I can remove all stones except one stone according to my need. Okay. According to my need. Okay. This is point number one. Now, how can I make the Iceland? Okay. Now you will select in typical Iceland, go to the next cells, go to the next cells. Okay. But in this, I want to traverse in the row. I have to make a Iceland in a row. So suppose if this is a row, if I'm starting here, then I can move to any stone in this row or in this column. So in this row, there is no stone, so I can't move. So in this column, there are. So I move to this position. Now, in this column, how many stones are there? So I can move to this stone also and this stone also. Then see any row, I have traversed that column. This. This is how I make the set. I said. Let me demonstrate in this. Now, see, I'm starting at this position. Now, any row, yeah, I move to this, it's under me. Okay, now all stones are completed. Now I move to column. Now the moment I go to column, I found one. This one. Now in this any row, yes, I move to this. Any column, no, as I have already traversed. Now I see row, it is already traversed. I go to column, I got one. In this row, yeah, I found one. Like this, I made a Iceland. So this hole becomes my Iceland. Like this hole becomes my Iceland. Okay. So okay. Now how many stones I can remove in this Iceland? See, read this. I can remove all stone except one stone. So I can remove all of them except any. So suppose I choose this. So how many how many times I remove? 1, 2, 3, 4, 5. Easy. Understood the concept? First, so first make the Iceland according to all the stones in the row and column. Understood? Then I can remove all stones and except one. Okay? So this is the two concept on which this whole portion stands on. Okay. Now the concept. How will I make the Iceland? So what I'm going to do is I'm going to make a hash map with the index of the row with the set of all the columns. Okay, suppose let's take a row 0. So I can say how many stones are there on the 0th and on the 1. So it would look like this. And for the column, it would look like 0 for this and 1 for this. Now suppose if I have to make for this one. So row, what is the row? 2. So it would be 1, 2. So it would be 1, 2. And column. So I am saying that in this row, on what index all stones are present? You will say 0 and 1. On this row, how many stones are present? 0 and 2. On this row, how many stones are present? 1 and 2. Index. Okay, understood? This is the whole concept. Let's put this up. So let's find the length and uh, I will so row and cost. Okay, let's make it. Okay, so this is my rows hash map and columns hash map. For j in stones. Okay, so there in Python there is a trick we can use one liner to store and check if an index is present in a row or not. So rows I and if j in rows as same for columns. So in this I'm going to store all the indexes on which this my stones are present in any of the row and column. Now I have written a hash map and now let's make FDFS. Like find the ice, make ice I comma j. And let me create how will I traverse in a DFS form? Suppose what I'm going to do is convert this into a set. Okay. Now, if I'm standing here, then I'm going to remove this index because I have traversed, I have picked the stone. Now, if I move to this stone, then I am going to remove this stone from my set. Okay. Then if I move to this, then I'm going to remove this. If I move this, I'm going to remove this. And if there is another stone present, like somewhere here, okay, so I will check if this is not present in my set, then I can traverse another DFS. Okay, so that's the next set of steps. Okay, so for now I will just pass and for I comma j store if I comma j in index, then I have to increase the count number of icons that I'm making, right, of ice and call DFS I comma j and ice. So how many icelands are making in the store? Okay, let's go there. Here, I comma j dot in index then simply return base condition. Now I have to remove it from the set as I'm going to traverse it. Okay, so index function. Or I can say how many I can store how many stones I'm removing. Okay. Now for J in I, DFS, uh, DFS, I, just this. And what I have to return, let's remove unhashable type. Let's, okay, I can't do like this because I can't hash a list. Right? I, if J, that DFS. Okay, okay. All I'm doing is those three. Okay, 6. Okay. Am I silly? Why am this? Serious. So what I'm doing is taking total number of stones that I have present, minusing how many Iceland that I made. And with that, I am able to find number of stones that I picked up. And it's been accepted. And population is concept. There was some mistake like yeah, some mistakes like so like but yeah, population is concept and here's the code. Taking two hash maps, row and columns, making a hash map, hash set for the stones index, finding the length of the stones, how many stones I have there, adding the values, okay, in the hash map, removing stones. That's now for every iteration, I'm checking if it is present in the index or not. If it's not, then removing it. And iterating over all the, like if I'm here, then I'll get this and this. Yeah. And all set as for DFS. Finding number of Iceland, how many times I'm calling the DFS. And with that, and simple. We'll understand this concept. And if you do, just give it a like and subscribe. And till then, see you and good luck.